In this video, we're going to talk about the characteristics of a sine and cosine function. So notice here that we have an example of a table with values for our sine of y equals sine of x and y equals cosine of x. Here we have our y equals sine of x function, and here we have our y equals cosine of x function. Notice that each lives between a range of -1 and 1. They each have maximum values and minimum values and x-intercepts. Our sine function starts at 0, 0, and our cosine function starts at 0, 1, each having an amplitude of 1, meaning the height from the x-axis up to the maximum is a 1. Each also having a period of 2 pi. We'll talk a little bit more about that in a second. So what are some characteristics of y equals the sine of x and y equals the cosine of x? So the domain of each of the functions is going to be all real numbers. The range of each function is between -1 and 1. So that means that the minimum value of each function is -1 and the maximum function, value is 1. The amplitude of the graph of each function is 1/2 of the difference of the maximum and minimum values. Or in this case, 1/2 of 1 minus -1 for a 1. Now, if we're not dealing with the parent function, we're looking at 1/2 of the maximum times the minimum. Now, each function is periodic, which means that its graph has a repeating pattern. So think of like a stamp. You have a stamp, you stamp it over and over and over and over and over again. So it's periodic because that repeats over and over and over. And so that shortest portion, that stamp that you're using over and over and over, that's what we call the cycle. And the horizontal length of each cycle is what we call the period. So the graph of each function has a period of 2 pi. The x-intercepts for the y equals sine of x occur at 0, plus and minus pi, plus and minus 2 pi, plus and minus 3 pi, and so on and so forth. Whereas the x-intercepts for our y equals cosine of x occur when x equals a plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, and so on. Now, when it comes to stretching and shrinking our sine and our cosine functions, because they do stretch and shrink, it's important to note that, it's important to note that if a is greater than 1, it's going to be a vertical stretch, and if a is between 0 and 1, it's going to be a vertical shrink. But notice that there's also a b next being multiplied with our x. So in this case, it'll be a horizontal stretch if the b value is between 0 and 1, and it'll be a shrink if our b value is greater than 1. Now, amplitude and period of the graphs of y equals a times the sine of bx and y equals a times the cosine of bx, a and b are both going to be non-zero real numbers. So our amplitude is going to be the absolute value of a, and our period is going to be 2 pi divided by the absolute value of b. Now, there are 5 key points to each of our graphs. See here, we have 0, 1/2 times our period, 1/2 times our period, 3/4 times our period, and then the end of our period. This breaks our graph into 4 equal parts. The 5 key points that we have are x-intercepts, maximums, and minimum values. So we're going to go ahead and we're going to look at an example where we're going to identify the amplitude and period of g of x equals 2 times the sine of x on the interval from -2 pi to +2 pi. So we're going to look at 2 periods here. Then we're going to graph the function and describe the graph of g as a transformation of the graph of the parent function of the sine of x. So here we see we need an a, b, our amplitude, and our period. We have an amplitude of 2 because that's in the a spot, and because there's not a b that we can see, it's a 1. So here we have that the amplitude is going to be the absolute value of 2, which is 2. And so we can graph our center line because that's not moving, and an amplitude of 2, so move up 2 and down 2. Notice that here I'm counting by 0.5s. Now my period is going to be 2 pi divided by the absolute value of 1, or in this case, 2 pi. So remember that we have our 5 key points that breaks our graph into 4 equal parts. We had the 0, the 1/4, the 1/2, the 3/4, and then 1 complete period. So we're going to multiply those by our periods. We'll plug our period in, and we'll calculate each of those values. So 0 times 2 pi is 0. 1/4 times 2 pi is pi over 2. 1/2 times 2 pi is pi. 3/4 times 2 pi is 3/2 pi, and 1 times 2 pi is 2 pi. So now we need to create ordered pairs. So we label our points on our graph, and we need our ordered pairs. So here we're going to put our x value in, which is our 0, pi over 2 pi, 3 pi over 2, and 2 pi. And our y values are simply our amplitudes, but it follows the pattern because for a sine function, we start at 0, 0, and then we go, so center line, maximum, center line, minimum, center line. And that's the pattern that repeats over and over. So we plug in our points, we'll have 0, maximum, 0, center line, excuse me, 0, center line, maximum, center line, minimum, center line. And it repeats the other way as well, but so that it creates this pattern. So we'll go to our minimum, center line, maximum, then to our center line, giving us our graph. And so this is what a sine function looks like. How exactly did this move? Because we see that our amplitude isn't just a 1. And so here we see that we have a vertical stretch by 2, as our a value is a value of 2, which is greater than 1, so we're seeing a vertical stretch here. So it stretched it 2 units.